Air pollution in America, a hidden threat that affects millions, but can we really fix it? Imagine waking up every day to breathe air that's slowly harming your health, from asthma attacks to heart problems. That's the reality for countless Americans, even decades after landmark laws like the Clean Air Act of 1970 aimed to clean things up. While air quality has gotten better overall, pollutants from everyday sources, like farms, factories, and even natural events, still pose serious risks. In this deep dive into the NASA Student Airborne Research Program, SARP, West 2025 Aerosols Group, we'll explore cutting-edge studies that reveal how aerosols, tiny particles in the air, trace back to agriculture, urban sprawl, and wildfires. These insights could shape policies and protect communities, but here's where it gets controversial. Are we overlooking the real culprits behind poor air quality, like industrial farming, in favor of stricter regulations elsewhere? And this is the part most people miss: how local geography and weather play starring roles in dispersing these invisible dangers. Let's break it down step by step, making complex science accessible for beginners, and see what sparks your thoughts at the end. SRP West 2025 Aerosols Group, NASA. Faculty Advisors: Andreas Barsdorf, California State University, San Bernardino. Graduate Mentor: Bradley Rise, University of California, Riverside. Martha Santiago, Northwestern University. Air quality across the United States has seen significant improvements since the enactment of the Clean Air Act back in 1970. That said, air pollution continues to be a pressing concern for millions of people living here. Everyday activities such as raising livestock, applying fertilizers, and using pesticides can unleash pollutants into the environment. These substances are often linked to harmful health outcomes, including asthma and cardiovascular issues, for residents in nearby areas. To understand the origins and effects of this pollution better, scientists look at aerosols as markers of agricultural sources. By studying their concentrations and chemical makeup, researchers can pinpoint where pollution comes from and how it impacts health. In this project, we're contrasting two key farming regions: California's Central Valley, known for its fruit orchards, nut groves, and cattle ranches, and the Delmarva Peninsula, home to numerous chicken hatcheries and vegetable fields. Using data collected in the air by the Aerosol Mass Spectrometer, AMS, we analyze the relative and absolute amounts of key ions like ammonium, NH4+, chloride, Cl, nitrates, NO3, organic compounds, and sulfates, so 42. We also calculate the total mass of fine particulate matter under 1 micron in size, PM1. Additionally, we investigate other farming-related pollutants, such as methane, CH4, which acts as a telltale sign of agricultural operations, and identify pollution hotspots in each area. Even though both regions boast intense agricultural activity, our findings show notable differences in their aerosol profiles and trace gas levels. On the Delmarva Peninsula, pollution seems to be a widespread regional problem, with average contaminant levels elevated, but spread out fairly evenly. In contrast, the Central Valley experiences more concentrated pollution, as evidenced by sharper spikes in pollutants that coincide with clusters of populated areas. By recognizing these variations in chemistry, amounts, and spread, local communities and decision-makers can develop targeted strategies to tackle air pollution and boost overall air cleanliness. But here's the controversy. Could stricter regulations on large-scale farming operations be unfairly burdening small farmers, while big industrial players skirt the rules? What if the solution isn't just more laws, but smarter technology to reduce emissions at the source? Eli Garcia, Trinity College. Aerosols are crucial players in the big picture of air quality, visibility, and human well-being, whether you're in a bustling city or a quiet countryside spot. In the sprawling metropolis of Los Angeles, a variety of human-made aerosol sources significantly influence the air, which, while improving, still lags behind national standards in this vast urban landscape. Due to Los Angeles's immense scale and varied terrain, the city can be split into several distinct zones, each with unique sources and types of aerosols. To dig deeper into these origins, our team examined data from missed approaches, those aborted landings during NASA's Student Airborne Research Program flights over the past 2 summers. These unique flight paths give us a precise view of the aerosol mix in neighborhoods close to airports, helping us trace the roots of these contaminants. For our investigation, we relied on aerosol mass spectrometer readings to gauge the proportions of organics, sulfates, nitrates, ammonium, and chlorides. We also measured the overall count of particles and the non-volatile particle count with a condensation particle counter. Data was gathered from 6 busy airports where these missed approaches happened, and we found that aerosol makeup shifts depending on the specific spot in the basin. At airports buzzing with heavy traffic and storage facilities, nitrates make up a larger share of the total mass, whereas at more industrial hubs like Long Beach, sulfates take a bigger slice. By identifying the main aerosols and their primary sources, we can prioritize cleanup efforts to cut down on these specific pollutants. And this is the part most people miss. Airports aren't just transportation hubs, they're mini pollution hotspots that might require tailored emission controls, like electrifying ground vehicles. But what if expanding public transit around these airports could reduce car traffic and, in turn, lower aerosol levels? Is it fair to single out aviation when urban driving contributes so much more to the smog? Kirsten Sundell, University of Rhode Island. Communities in California's Imperial Valley face asthma rates that soar well above the state's average for every age group, even with relatively modest readings of fine particulate matter, PM2.5 and PM10, at official monitoring sites. This puzzling gap between health statistics and pollution data hints at hidden sources of emissions in an area dominated by massive industrial cattle operations. The Imperial Valley is home to California's biggest concentrated animal feeding operation, CAFO, and slaughterhouse, where thousands of cows are housed, generating huge amounts of methane, particulate matter, nitrous oxide, and ammonia. These gases form intricate aerosols that are tied to breathing problems and heart conditions. Past research has employed filters for total suspended particles, computer simulations of how pollutants spread, and tracking of supply chains to evaluate CAFO emissions, but these methods often fail to spot dense pollution zones. In our study, we blend airborne aerosol data from NASA's Student Airborne Research Program with information from EPA air monitoring stations, IPCC estimates, and California's wastewater permits. This allows us to measure and map emissions from the state's top cattle facility, Brant Beef in Calipatria and Brawley. We cross-reference this with health and demographic info from the California Department of Public Health and the CalEnviroscreen tool, uncovering strong links between pollutant distribution and health markers like asthma and cardiovascular disease. Our calculations show that Brant Beef releases about 26.73 tons of methane and 39.98 tons of nitrous oxide each day. Aerial scans detected higher PM levels near the sites, and location-based analysis confirmed ties between closeness to the facility and health problems. These results point to significant environmental effects from large cattle farms on nearby populations, potentially explaining disparities in health, even when operations meet federal air standards. But here's where it gets controversial. Are these compliant facilities really safe, or do current regulations allow too much leeway for industrial-scale farming? Could shifting to smaller, regenerative agriculture practices cut emissions without hurting food supplies? And what about the economic toll on rural communities if we crack down on these operations? Is it worth the cost to public health? Lily Kramer, Oberlin College. Dust storms kick up when strong winds lift loose dirt and soil, posing serious health risks to people in the vicinity. The biggest source of such dust in the U.S. is California's Owens Dry Lake, where these storms carry dangerous carcinogens from the exposed lakebed into the air and toward populated areas. Another shrinking lake, the Salton Sea in California, is following a similar path, revealing more of its playa to the elements as it dries out. Its decline echoes the fate of Owens Lake, which evaporated completely by 1905. A 2024 study by Eric C. Edwards and colleagues, using a detailed particle transport model, showed rising dust outputs from the Salton Sea. Our project builds on that by presenting new environmental proof that the expanding playa is ramping up dust production.